Fire Accidents and Risk. A 43-minute presentation sponsored by Professor Brian Collins from the Department of Information Systems, held at the Lander Theatre, Shrivenham on the 6th of December 2005. The speaker is Professor Helen Muir, OBE. Professor Muir is the Director of Cranfield Institute for Safety, Risk and Reliability and Head of Department of Human Factors and Air Transport at Cranfield University. She is a chartered psychologist with a particular interest in human factors safety research. The resource she established at Cranfield has become a focus for European cabin safety research. As a direct consequence of the scale and success of its activities, the UK is widely recognised as world leaders in this field. Professor Helen Muir.
I want to talk in a moment about the Cranfield Institute for Safety, Risk and Reliability. But human behaviour and our behaviour, I can put my human factors hat on, is very much about understanding the risks we're taking. In a sense, how we perceive the world about us is to a large extent influenced by what we think the risks will be of getting it wrong, the importance of getting it right, the frequency with which we've seen it before. We make all these trade-offs as we assess what's going on around us. So it is very fundamental to how we, if you like, as the human information processing system, work. And I think it would be very interesting on another occasion to look at the similarities and differences between how the human decision maker works and how you, with your very clever systems, make decisions. Having said that, I'll now come on back onto my agenda. Some years ago, as some of you will know, I was the Pro-Vice-Chancellor. On one particular occasion, the Vice-Chancellor was going to give a lecture at a dinner in the House of Lords, and he said to me, "Helen, what do we have that goes right across the university that I can talk about?" So I thought a little bit, and of course you think from your own perspective. I said, well, possibly safety, Vice-Chancellor. "Oh, yes, good idea, Helen, OK. And what are the big safety issues?" So I pulled myself together and I said, well, I think there are two things. Firstly, how safe is safe enough? Because we don't all agree about that. We know that we actually tolerate in the UK killing 3,500 people on the roads. The same number, interestingly, that were killed in the Twin Towers accident in the States. But, as you also know, we kill 3 people because of a few cracked rails and we stop half the rail network. So I think one of the interesting things in terms of risk and safety is how safe is safe enough in the various sectors of our industries. I think the other question which falls out of that is, when you've decided how safe is safe enough, how do you get it? How do you make systems safe? One of the interesting things that we've done as part of establishing this institute is to think about, well, how does safety and risk relate? Because we have all these people doing risk analysis, people like myself doing safety analysis, people in the School of Management who are very good at telling you how you can build a reliable organisation, but we pass like ships in the night. We never do common projects, we never do common bids, we very rarely sit around the table and discuss it. So, to cut a long story short, as a result of this lecture for the Vice-Chancellor, which I'm pleased to say went extremely well, and all of the industrial sponsors thought it would be a good idea for us to take this up, I was asked whether I could develop this for Cranfield. And so putting together a small group of people from across the university, we decided it shouldn't just be about safety, it should be about safety and risk and reliability. And some of you may also add, and possibly resilience. And that the Vice-Chancellor initially would give us some cross-campus funding to start this activity off. It is still a virtual activity in that we don't have any formal infrastructure. We just have a group of, I must say, very committed academics from within Cranfield, and then we have an industrial advisory board with people like the chief scientist from the Health and Safety Executive, the head of research from the CAA, the head of safety from Transco, various people from the various sectors. And we would on another occasion like to discuss more representation from you at Shrivenham. As you can see, we have a website, and I would urge you to look at that to find out more about us. We've set ourselves some objectives. The first one is essentially to establish a new brand, enhance the promotion of Cranfield's research and teaching by creating a new brand as a focus for safety-related activities at Cranfield. I mean, what we want, ultimately, the marketing people will tell you is, for the UK, think safety, think Cranfield. Think risk, think Cranfield, across the sectors. It's a big goal, but there's no point in having little goals. You want things you can go for. Development of an organisational infrastructure to encourage and support cross-campus collaboration in research, consultancy and teaching. We're slowly learning how to do that a little bit better, but I'm sure you will all share with me, it's not easy. It's not easy even to find who your opposite number would be on another campus. And one of the things we're doing, and you'll find on the website, is to put together some of the people and the themes so that increasingly this is easier to do. And of course, being Cranfield, we all know the bottom line matters. It's the one thing the heads of schools really count. So to generate new revenue from this activity. And we are starting to make some progress, but it is slow because it's virtual and we don't have any permanent resources. But when I point out to you at Cranfield, on the various campuses, we have significant activities in all of these sectors. I mean, it's quite an impressive list, isn't it? And when I say to you, and this isn't all of the areas, but the sort of capabilities we have, it's very impressive. I mean, we do accident investigation in quite a range of areas, and we've actually, since then, can add marine to that top line. We do safety and air traffic control, we do aviation cost-benefit analysis. You can read these gently at your leisure. But I think when you consider all of these areas, we've got huge potential. The trouble is, we're all sitting in our little boxes, minding our own business, trying to get the next bit of work in. And what I'm urging you to do is to please look at our website. If you want to contact my office and we can help and facilitate, we'd be delighted to do that. We've got lots of big plans. We do have practitioner lectures. We've had one with Timothy Walker, who is the head of the Health and Safety Executive. We had a very interesting about how the HSE tackle safety, risk and reliability. We had a very interesting lecture from the Chief Executive of EasyJet about how they cope with safety and risk. We've got Eliza Manningham-Buller coming early in the new year. We also run seminars. We've only, I'm afraid, held them so far on the Cranfield campus, but for staff and students to see some of the activities and have to debate some of the issues on which we have expertise. For example, we had a very interesting debate on nanotechnology from the professor. I mean, is it really a worry or is it not? We're doing one on safety and some of my passenger safety activities early in the new year, and we have a programme which again will be on the website. I can go on. I think perhaps the one I would like to just spend a couple of minutes on is we have a suite now of safety-related Msc courses, and again I wonder whether this isn't an area where we could have some common elements and modules and sharing. We have safety and human factors in aeronautics. We have a safety and human factors for the Health and Safety Executive on health and safety at work. We're developing one on patient safety in medicine with the National Patient Safety Agency. We have other accident investigation courses, and so we're slowly building up this suite of safety-related MSCs. And I think it's very interesting that students from one sector really seem to appreciate mixing in the class with students from another sector and comparing how they do things. And I was interested last week. I was lecturing at the National Patient Safety Agency at a conference they were running on confidential incident reporting, because for my sins I chair the Rail Confidential Reporting Programme. And I'm sure, I don't know, but I would believe in the military, in all of the transport systems, if you do something that's very seriously a risk, that you have a mandatory reporting process. Certain things in aviation, if you have an altitude bust, in other words, you drop below the height you should be flying, you have to report it. We have other things in rail and so on. In medicine, they don't have any. If a surgeon nearly kills somebody, he doesn't have to tell anyone. It's optional. And they do now have a National Patient Safety Agency, and they have an extraordinary number of now and towards events reported each week. But the reason we're talking is so that they can learn from us and we can learn from them, and that's the point about this. They're actively trying to sort it out. It isn't that there's a stalemate at all. And what the nice thing is, we're trying to help them. Okay, I'm now coming off my soapbox about all of this because I'm going to now talk about what really interests me, which is my research. And the research which we've been doing in the Human Factors Department at Cranfield, one of the lines of the research, we do quite a number of areas, but one of them arose out of an accident which happened 20 years ago now. You may remember it, those of you who are old enough. It was the accident which happened at Manchester Airport in 1985. It was a 737, which is one of those aircraft you go on holiday on with an aisle down the middle and 3 seats either side, and it caught fire on takeoff. And tragically, 55 people lost their lives. And you may say, well, that's not a surprise, Helen. But actually it was. And the reason it was that when all new aircraft are built, the manufacturers have to perform tests to show that you can get all of the passengers out of half the exits in less than 90 seconds. And the reason we do these tests is because if an aircraft catches fire, and in the majority of accidents where loss of life occurs, there will have been a fire, there's typically only 2 minutes from the first spark to the conditions in the cabin being non-survivable. So we know we've got to be able to get everybody out quickly, and we've religiously done tests of every new airframe and demonstrated, as I say, we can get all of the passengers out through half the exits in 90 seconds or less. In this accident, there was over 2 minutes with half the exits operational and 55 people died. And the question is, why when we tested it and it didn't matter, did we succeed? And why when we really needed it, did we fail? And that was lack of information. And that was a lack of understanding of the perception of the risk and the behaviour of the passengers as a consequence. Having said that, well, OK, what did happen? Why did it go wrong? And that was, I would say, was what made the engineers and the regulators, for the first time, come and talk to the psychologists like myself and my opposite numbers at Farnborough and say, well, what went wrong? Well, when we talked to the accident investigators, 2 things became apparent. A, at the small overwing exit here, when the fire came through the back of the cabin, everybody rushed forward and this exit became blocked with people trying to get out who tragically were burnt alive. Again, other people rushed to the front of the plane, and if you recall on these planes, you have the rows of seats, and then you have a wall, a partition either side with a gap which has to be at least 20 inches in the middle. We call them bulkheads in the trade. And what had happened is people rushed forward, and when they couldn't all get through this 20-inch gap, some fell and were trampled on by others, and that led to congestion, and hence the flows were interrupted. And that's what I say about people and behaviour. When we do the tests, everybody behaves perfectly and comes out in straight lines like a school line. When you're in a situation where you've got a fire, and I don't think it makes any difference whether it's an aeroplane, a boat or a building, when you're in a confined space and you perceive a life threat, you don't stay in straight lines, you go for what you think you can do to survive. And it was that survival instinct and that behaviour which the industry hadn't considered in its plans, and now to us becomes so apparent. So it's a very sad story, but it's a story that opened people's eyes, and it gave us the opportunity to say, OK, if we haven't got the right information, how do we get the right information, and how do we change this to stop it happening again? And for my sins, I was the lucky lady who got the contract to look at that. But it wasn't easy, because whereas I give you this explanation, and I hope it's been plausible enough for you to consider it might have some semblance of truth in it, the Americans, on the other hand, really didn't want the English starting to do independent research on aircraft dimensions and safety, and so they put up quite a strong campaign that, people in England may behave like this, but people in America don't. Until, to their shame, they had this accident a few years later, again, a narrow-bodied aircraft, again, half the exits operational, again 50-odd fatalities. Oh dear me, 2 gentlemen had an actual fist fight about who was coming out of the overwing exit first. Tragic. And the Americans, to their credit, said, sorry mate, this is human behaviour. And it was good because from then on we collaborated with them over the research. And so that was a plus. But the tragedy was we'd had to learn it the hard way. But not all accidents are the same. We can learn a lot about human behaviour from different accidents. I'm sorry, I've only got 2 more of these, and we'll then get on to the research. But this is an accident which happened at Calgary. Again, a similar sort of airframe. Again, a fire. Again, 2 minutes with half the exits operational, and everyone survived. So the question is, why did they survive at this one and not at the previous two? Answer, this was a commuter aircraft. The passengers did the flight almost every day. They knew the aeroplane backwards, and when the evacuation happened, they came out of straight lines as per the plan. So as long as people behave on the plan, it's fine. By contrast, at Manchester, it was a charter flight, they were going on holiday, there were families and friends, and they may have probably listened to the pre-flight briefing, but they didn't really know what to do, and it became chaotic and disorganised. So we know it's not just how the aeroplane's configured, but it's who the people are, what they do, and so on. And my final accident, this was New York. You may remember it. It was a fire with a large, wide-bodied aircraft. In other words, the sort you go across the Atlantic on. There were 280 people on board. Again, a fire. Again, 2 minutes with half the exits operating. And all 280 people got out. And when I spoke to the accident investigator, I said, how come they got out of this one and not out of Manchester? Oh, he said, in this American drawl, which I can't do. Easy, Helen, easy. 2 reasons. A, no small type, through what we call overwing exits, those small type 3 exits, which do get blocked if everybody rushes. But B, he thought much more importantly, the Transworld fly with a minimum of 6 the aircraft certificated for a minimum of 6 cabin crew for safety purposes. Transworld offer quite a high level of service, so they fly with 9 cabin crew. Very luckily, on that day, there were a further 5 members of the company who were cabin crew who were flying as passengers and who helped with the evacuation. So instead of a minimum of 6, you had 6 plus 3 plus 5, and all those people worked together, and they kept control of the passengers. They stopped the rushing around. They got optimum use of the exits. They kept it orderly, and of course it behaved as in a test, and it was very successful. So summarising or pulling some of these things together, we know now quite a lot about what influences survival in aircraft accidents. What we don't know is how to make them better. We know, okay, crashworthiness is important. What we want to do is stop the fire coming in and spreading. We do now have, since Manchester, increased seat strength, fire-blocking materials and so on. But we know the layout matters. We know also that the number of crew and how they perform matters. Obviously, if you've got smoke and toxic fumes, then that's an issue, and we have got other devices now to help with those. We've, since Manchester, done a lot on evacuation aids, exit signs, full proximity lighting. We're about to look at directional noise again. But perhaps more important than anything else, we know it's the passengers and their behaviour and their interpretation of their situation and their knowledge of what to do. There's been a big study done in the United States on people who've been in accidents, and it's very clear. People who know what to do have a much better probability of surviving accidents. The problem is, many people, contrary to reality, think if you're in an aircraft accident, you're going to die, and so there's no point in looking at the safety briefing because it's not going to make any difference. And it's just wrong. In 93% of accidents, some or all of the passengers and crew survive, and those that know what to do have got a better chance than those that don't. The problem is the accidents you see are the ones where there's a massive fire and half the people do die. If an aircraft, say, has a nose wheel collapse and everybody gets out, it hardly makes the newspapers at all. So I don't want you to go away from today thinking aircraft are dangerous. They're not. One other thing about the Manchester aircraft, this is a simulation, but it's based on Manchester. It isn't that it's a simple picture. You can see here the people who sat in the blue seats used this forward exit, people in the red seats this forward exit, yellow seats this exit. These exits weren't usable because of the fire, and the red dots are where the fatalities were seated at the start of the evacuation. Now obviously some people do use their nearest exit, but others don't. Others travel from the back here, can travel from the back and get all the way to the front. Now we don't know who they are and how they did it, but it's not just where you sit. Equally, some people very near don't make it. So we know we've got a confused picture. As I said, at Manchester, we had this exit blocked and we had fatalities here at this gap. We were asked after Manchester what we could do to help the regulator stop this happening again. You can't actually scrap all 737s. There are more 737s than anything else. What you've got to do is to think, well, OK, what can we change to improve the situation? So they asked us whether, if we could make the gap between the seats bigger here, it would make a difference. And if we could make this gap wider, it would make a difference. And could we test that? And I said, yes, we could test it. And Boeing said, oh, because Boeing didn't want some little lady in England telling them how to build their aeroplanes. Yes, I said we could. And they said, but we've done it. I said, well, how did you do it? Like an evacuation, what we call demonstration? Yes, they said. I said, well, we've got to do something else. And this is with my Mrs. Human Factors hat on now. What I had to produce was the motivation that people do have in an accident when the plane's on fire. Now, we as psychologists do some pretty dreadful things, or have in the past, but we couldn't actually put members of the public on a plane and set fire to it and see what happened. Actually, they did do that in a helicopter in Scotland once. They got into a lot of trouble. But somehow we had to... one of the challenges, and I think this is an interesting fundamental question, how do you, if you're wanting to test a system for use by people in an emergency, do a test without actually putting people at risk and injuring them, mentally or physically? And it's that trade-off that we play with all the time when we test our safety systems. And that's what I had to play with. So to cut a long story short, we designed a test program so that we could look at changes to the gap between the bulkheads at the front of the cabin. Actually, in our plane, it was part way down, but we could look at that. And we designed a test so that we could look at changes to the seating beside the overwing exit. We recruited members of the public because, as a good psychologist, I had to have a Latin square design and it all counterbalanced so I could do the right analysis of variance and so on. But our members of the public came in groups of 60. They were told they would take a part in 4 evacuations, and we did as much as we could to make it as realistic as possible. We had cabin crew showing people to their seats. We had a pre-flight briefing. We had the noises of an emergency. And then they would hear the instruction from the captain, undo your seatbelts and get out. And when they heard that instruction, they knew they had to get out as quickly as they could through whichever exits we opened. And we changed what we opened and where they sat and all that kind of thing. What they also knew was, though, that the first half out of any exit we opened would get a $5 straight away in their hand. And that changes human behaviour in a most remarkable manner. And it sounds like a very simple idea, but what I had to do was make people determined to get out, because then I could say, well, when they're doing this, how big should the gap be? And we would know. And basically, that's what we did. We didn't use slides in this one. We used ramps because I was worried about injuries, because, of course, that's the other problem. If they got out first, they got a ticket on the ramp and they went to the caravan and swapped it for a $5. People are appalling, If on the first evacuation they got a $5, they were going, well, I think they were pretty good. Those that hadn't were determinedly going to do better next time. It was extraordinary. Now, I'm going to stop talking about it and I'm going to show you. We're going on to videos now. This is the first experiment, pre-flight briefing. I think you'll agree it's pretty like the real thing. It felt like you were going to take off when you were in there. We all used to get a bit tense beforehand. Now here's coming through the 20-inch gap at the front of the aircraft. And it's easy to see why, when 150 people are trying to get through there, why you've got a problem, isn't it? And see how important the cabin crew are. Easy to see why the terrible situation had occurred at Manchester. Now they're not in the first half and they haven't got a problem. See? It's only when they're competing. Now, make the gap wider and you improve the situation. Using this methodology, we could show what would be an improvement. Again, you can see the cabin staff matter. And this is what it was like inside. People if you didn't get out quickly, someone went over you. And when we saw survivors from Manchester came and saw these videos, they said, yes, that's what it was like. That was the terrible thing. It was like. The simulation was extraordinary. Now we do another one without motivational payments, without £5 bonuses, and you can see there isn't a problem, even when the gap's narrow. And that's why it had never been predicted. We then had to replicate in smoke because the regulator said, oh, well, it's smoke really that when these accidents happen. Here's the girl with the tickets. If you get a ticket, I said you get a $5. In smoke, it's interesting. People come out in bunches. In smoke, you have a leader and so many followers, just like cars going up a motorway in fog, a leader and then followers. But we needed to check that our results would still be okay in smoke. And I'm going on now through a series of edited highlights of all sorts of things we've done. The overwing exit we opened with our team. In reality, passengers would open it. Look at this. Easy to see what happened at Manchester and at Los Angeles, isn't it? And you won't have a friendly fireman to help you. You'll be on your own, or with your family. But you can see the problem now. And this is just for £5. This isn't because you've got a fire behind you. And these aren't all Cranfield students. They're people from the general public, of all ages. Well, not all ages, 20 to 50. Easy to see the design fault there. And now you'll find the first half have got out and they're not going to fight against each other anymore, and it's no problem. It's only when people are trying to get ahead of each other, as in an accident. Now, make the gap between the seat rows wider and you get a much better result. They're still competing, as you can see, but give people more space and it helps. And members of the public should open that door, not the fire officer we employ. So here you can see one where, just, you know how you get on a plane and a group of passengers takes on a personality? Well, so they did in our experiment, and sometimes they were very aggressive, and we had to have an emergency stop procedure if we actually blocked the exit to prevent injuries. And this was an example of one of those. The numbers on the bibs were there we are, we've just decided it's too dangerous to continue. And this is what it looked like inside. The numbers on the vests were the numbers of the seat they sat in for that evacuation, so we could, on our videos, work out who came from where in what time. Now, no competition, just like a certification test, and no problem, even with a narrow gap. In smoke, we wanted to see whether all of the recommendations we were making in clear air would still be okay in smoke, which is why we did these. And again, in smoke, you can see we've got all the same problems. This is members of the public opening this exit, which is what has to actually happen in an emergency. These people know they're in the test, they know they're getting bonus payments, they're desperately trying to do it. And what I think it shows is that this isn't an ideal design for an exit. And you've only got 2 minutes, and look at the time it's taking. And actually it weighs 44 pounds and it killed someone when it fell on the Manchester. But I think you can see that even though people knew they were getting out with an incentive payment, it is a very difficult exit to operate. The other thing is that they're told they won't get the bonus payments if they don't do it correctly. When you sit in these seats, you'll find you quite like them because you have more legroom, thanks to my experiments. You should look at the placard in front, because if you're required to open this exit, it isn't, as you can see, a piece of cake. And what was interesting was, not just that we get these problems, but you'll see in the next 2 film clips, people don't do it correctly. You're instructed to throw it out. They haven't. And my point about this is, if you want people to operate a piece of equipment correctly in an emergency, you must make the design what I call intuitive. It must be intuitive to do the right thing. And that applies not just for members of the public, but it applies on flight decks, it applies on bridges of ships, it applies on your IT systems, wherever. Look at this. In and then out. Nearly broke the leg of the bouncer. So we were starting to learn quite a lot about these exits. We do think, actually, at Cranfield, we know probably as much as anybody does about how these things work. What we were asked then to do, our engineers were asked to do, was to redesign the operational mechanism and make it more user-friendly. So in the clip that follows this, you'll see this exit being operated, by an individual in perfect circumstances. You can see what a nice, friendly thing it is. It weighs 44 pounds, but she's managed it. Next clip, you'll see the Cranfield redesign being tested. Big improvement. Now you retest them with an incapacitated passenger sat there. This is looking at assertive behaviour by cabin crew. Now I think you can see she's got them very assertive and going very fast. And that's what needs to happen. We did this study because we wanted to provide information for cabin crew and cabin crew training. I think when you see now she's non-assertive, in other words, she's not pushing and shouting, she's telling them and letting them decide, it's a lot slower. You asked about the dimensions. At the front of the aircraft, we looked at a gap of 20 inches right through to 72 inches, which is the equivalent of removing the section on one side. We had 60 people on the aeroplane. The first 30 were getting bonuses, so we took the average time of the 30th person out of the aeroplane, and as you can see, as the gap gets bigger, the time to get 30 people out reduces. The interesting thing is, and at what point does it change? And statistically it changes when you get to 30 inches. So we were able to say very clearly to the regulator that was our recommendation. It's still being argued about. The interesting one, though, was the 72 inches, removing a bulkhead. And I think this is why I would say to you, it's all very well to do simulations, but when you do realistic testing, you learn more very often than just the answer to your hypothesis. Although 72 inches gets the people out in the shortest time, on occasions, as the cabin crew was opening the door, and that's an up and over door in this instance, she was pushed out backwards by the passengers. And that has happened in accidents, and cabin crew have lost their lives from that. Whereas we found that if there was a bit of a bulkhead, she had something to protect her from the passengers, and so we said that although that was that the fastest time and a statistically significant difference, it wasn't one we could recommend, whereas there was no difference between those two statistically. And that's why I make the point. It's all very well doing simulations. They will probably give you the answer to the question you've raised. What they won't tell you is anything else about it. And I really feel quite strongly about that. At the overwing exit, interesting, we looked at a gap between the seat rows. Aircraft seating is complex to understand the measurements, but aircraft seats sort of float back, and then the seat behind comes almost underneath. You know, you've got this in your face sometimes. And the minimum gap that is allowed is what we call a 3-inch vertical projection. In other words, 3 inches from the furthest point back of this seat to the furthest point forward of this seat. And that's what you get on charter aircraft and so on. So we looked at 3 inches, and then we went through a number. And this is the time for the 30th person out and averaged, and you can see that this is where the significant change happens. And I'm very pleased to say that the European regulation is now 10 inches. So that was nice. You asked me about people getting bonus payments. We did 4 evacuations. We arranged the seating so everyone should have an equal chance to stop any arguments. So if the world was fair, and we all know it isn't, everyone should have gone away with 2 out of a possible 4 bonuses. As you can see, 37% did that. Interestingly, some people are life's winners. Some people, it doesn't matter where you put them, they get bonuses every time. Where you put them, they'll get out. There are not many of them, but we didn't have an equal number of males and females on the trials, but you can see that this has got the greatest percentage of males and that they're slightly younger. Some people are life's losers. Doesn't matter where you put them, they don't get out. But my point is, people are different. And that's what we have to, I think, understand. And I'm bringing this out because it doesn't just matter in aviation. I think it matters in terms of how people use your IT systems, your knowledge-based systems, and so on. We've done lots of other things. I think the other point I might like to make here is, though, that about perception. I started talking about perception and decision-making at the beginning. One of the things we know that survivors from accidents, when they're interviewed, generally say it was quiet, no noise. How can there be no noise when an aeroplane's on fire? You know, fires make noise and pops and back, but they don't hear it. I was very interested when on the end of the first day we did these tests, a friend of mine who'd been one of the participants came up to me. She said, "Helen, why did you have all that noise on the last evacuation of people screaming after the call to evacuate and not on the first 3 trials?" I knew the noise had been there all the time. So I said to her, "OK, Kath, what was the difference for you between the first 3 trials and the last one?" "Oh, easy," she said. "From where I was sat in the first 3, I thought I'd got a chance of getting out quickly and getting the bonus payments. And so I went for it." And so she put all her attention and her concentration in her visual modality, because that's what she was using, and she went out and she got her bonuses, just as people do in accident. But on the last trial, she was sat at the back, the doors at the front. She said, "I knew I hadn't got a hope." I sat back and waited. I hadn't got a hope of getting the money, so she sat back and waited. Of course, she heard it all. What I just thought I'd spend a couple of minutes talking about is these very large ones that are coming up. Because I think they do present a challenge, and I think they present a challenge about information we don't have. How many cabin crew do you need once you start getting 800 people on an aeroplane? Is it just that you can stick to a ratio of 50 to 1, or do you need to gear up? What happens when all these people, 800 people, are outside the aeroplane unsupervised. For your information, if you ever have to do an evacuation, and I hope you never will, the time people get injured, and they do get seriously injured with broken backs, is if they come down the slide and they stop here, someone else comes into the back of them. So the key thing is, when you get to the bottom, run like the proverbial and get away. Very, very important. There are all sorts of issues about the stairs. Will we use them in an emergency? Won't we use them in an emergency? We're going to base our tests on the assumption that no one in an emergency will ever use the stairs. I have to say, I think that's a little naive. Because if I was on the upper deck and I was sat near the stairs and they said evacuate, I'd go straight down the internal stairs and come out of the lower deck rather than that top one. So we continue to have knowledge questions. A blended wing aeroplane, I don't know whether you've seen them, but there has been a proposal by Boeing to develop an airframe in the shape of like a stealth bomber, because it's very aerodynamically far more efficient. And we've actually built one of these on our mock-up at Cranfield, or a half one. I'll show you our mock-up in a minute. And looked at the issue of how do you get people to know where to go, how do you communicate. Actually, we really know how to do it. Now, we do have this test rig at Cranfield, which one or two of you, I think, have seen. And I'm sorry about all this engineering thing, but, engineers, you always overcrowd things and so on. But what it is, essentially, is two platforms. It's a gantry, a huge platform at 5 metres, which is the height of the floor of a 747 or an A340 or the A380, and an upper gantry, which is at the height of the upper deck of what would be the A380 at 8 metres. And after that, it's Lego. So I can make any airframe of any size. I can move doors. I can change aisle widths. We can do what we like. And we have had it as a blended wing, but of course I can't show you. But we've had it here. You can see we're looking at issues with the upper deck slide and so on. And we've had a lot of people through this, and we've shown that you can get people to come out of these high exits with suitably trained and assertive cabin crew. So it isn't all doom and gloom. At that point, I'll stop talking. If there are things you want to ask, but I think my message is we do need to do real testing to get real information. And it needs to be realistic. The problem is when it's safety information or systems to be used in an emergency, how do you control the risk to your participants whilst at the same time providing a realistic test? Thank you very much.
Professor Muir was asked the following 5 questions. Question 1. How do you stop people taking their hand luggage off?
Extremely difficult and extremely dangerous. There was one terrible evacuation in the States where a lady had bought some liquor in a glass bottle and the crew failed to take it off her. She went down the slide. When she got to the bottom of the slide, it smashed into her lap and cut her very badly. But that was the beginning. Everybody who came down behind her, possibly without shoes on, sat in it. So it is extraordinarily difficult. And we all like to do it. You see, whenever we don't like to be parted from our personal things. There was another terrible accident when everybody got off. While the people were waiting to be rescued, some of the gentlemen thought they'd go in and get their ladies' handbags, and while they were on the plane, it blew up.
Question 2. As most people will never be involved in a major accident, what is the cost-benefit of them learning how to escape from every form of public transport versus the actual risk?
Well, technically you're correct. There are probably better things you might be able to learn to save your life. But actually, I have to say, I think we've got, in aviation, safety briefing wrong. It's now so long that people who fly frequently don't want to listen. And people who don't fly frequently can't remember it all. So we're losing the baby with the bathwater. So I am urging the industry, and I go around the world campaigning on this one, to rethink this. We've got new technology now, and this is again where how we give information to the people and how relevant we make it, and whether we can give it in small, short, discrete chunks when they need it. I think there's a whole piece of work to be done there, and I think it will be a safety improvement.
Question 3. Do people sitting by the doors need more training?
There's a lot of debate about this, and I think it has merit. I think the thing that's dogged us in the past, I suppose I should say, is no aircraft operator wants to give anybody any safety training at one level because they're frightened of putting off passengers. It's always been, if we talk to them about it, they might get fear of flying, and there is obviously a slight risk. My argument to them is that actually, if marketing is so clever that they can write on a packet of cigarettes, "This is going to kill you," and sales don't go down, we can surely work out how to give people some of this information.
Question 4. How do you factor in that in an emergency, some people don't move immediately?
This is where perception comes in, and there's two parts to this answer. In our experiments and in accidents, some people move quickly and some people get what we call behaviour in action and get stuck. So you have a mixture. But there's another interesting study that was done about the evacuation of a shopping precinct. And this experiment was done during the time the IRA were bombing Britain. And the first evacuation they did one day was they said there was a fire. And I think it took 25 minutes to empty the shopping precinct. On another day, they said there was a bomb and it took 4.5 minutes. So this is where perception comes in. And there was a terrible fire in a Woolworths store where people sat and finished their meal. So it's all about how we perceive the situation. And the cabin crew will tell you, if there's a fire, people perceive it pretty quickly as something. We all know fires are bad news on aeroplanes. But if there's a need for an emergency evacuation, say the flight crew think there's something wrong, but actually it turns out to be a false warning, the cabin crew can have great trouble, A, getting people to move, and B, to leave their possessions behind.
Question 5. Would smoke hoods be useful to give people extra time to evacuate?
Smoke hoods are an interesting and very difficult subject. After Manchester, there was a great push for smoke hoods to be introduced, and a lot of companies did a lot of research into smoke hoods. The CAA produced a spec, which was that, and it, in the face of it, at the time, it seemed a quite reasonable spec. They said, well, how long is it going to take if we have an onboard fire to get the aircraft down somewhere? And they came to the conclusion that probably in about 20 minutes in most places you could get the aircraft down. So we want a smoke hood, therefore, that will keep people alive for 20 minutes. What's also important, though, is that you don't have a smoke hood, which people spend so long fussing to try and get on, that they delay in terms of getting out when they really need to. So the next bit of the spec was, I can't remember the exact figures, I think you have to be able to don it in less than 30 seconds. So now you're talking about, and smoke hoods are, if you like, a version of putting a polythene bag on your head. You're talking about a piece of kit and there can only be one size, we can't have different sizes and people scrappling around. And so you need a piece of kit which will fit certainly any adult. And we all have different head sizes, and sometimes we wear glasses, and you don't want to be blind in your smoke hood. And people have turbans and headgear, and really, it proved too difficult to design and if it's going to keep you alive for 20 minutes, it's got to have quite a tight neck seam. So it proved to be too difficult to get something which would not potentially slow people up getting out, but would keep them alive for that period of time. And they were dropped. Having said that, I'm not an engineer, probably some of you are, but I do wonder whether something a bit like a damp face flannel that you could pull out of the seat in front of you, and if you got one it might help, and if you didn't, well, you're only back to square one, would be worth a thought, but nobody seems to have produced one.
Professor Muir can be contacted by email at h.muir@cranfield.ac.uk.